Good morning, dear student. Our today's topic is defects in solid. So let's start defects in solid. As we all know, solids are formed from many small crystals. However, during the process of crystallization, the defects in solid occur due to the fast or moderate rate of formation of crystal. So, defects in general are defined as those in which there will be irregularities in the arrangement of constituent particles. On the basis of irregular arrangement, the defects may be as point or line defect. As we know, according to the third law of thermodynamics, at absolute 0 Kelvin temperature, any substance will be perfectly crystalline, but on increasing temperature, defects in solid are created, which are classified into following three types. First one is stoichiometric defect, second one is non-stoichiometric defect, and third one is impurity defect. Now we will discuss all these defects one by one. In stoichiometric defect, in which stoichiometry of the compound remains the same as shown by their chemical formula, it is also called an intrinsic or thermodynamic defects. It is further divided into two types. First one is Schottky defect and second one is Frankel defect. Schottky defect occurs due to the missing of the same number of cation and anion from the lattice side. This type of defect is shown by the substance which having high coordination number. And Schottky defects generally occur in ionic compound in which the radius ratio of cation and anion is not far below unity. It is a kind of vacancy defect where an equal number of cation and anion are missing but maintain the neutrality of the crystal. The density of such type of a crystal decreases due to presence of ion. This crystal can conduct electricity to a small extent. Example of Schottky defects are NaCl, CSCl, KCl, AgBr, etc. In Frankel defect, some cation are missing from their lattice site and occupy the interstitial site of the lattice. This type of defect is shown by those substances which have low coordination number. The closeness of like charge tend to increase the dielectric constant of the crystal. Frankel defect is a kind of dislocation defect or interstitial defect in which the smaller ion, generally cation, dislocate from their position to occupy the interstitial site of the lattice or crystal. The density of these type of crystal remain the same because there is no movement of ion outside the crystal. Frankel defect is exhibited in those ionic compounds in which the radius ratio is low. Example of Frankel defects are zinc sulfide, silver bromide, silver iodide, and silver chloride. Seen that AgBr show both Frankel and Schottky defects. Now move on the non-stoichiometric defect. This defect is shown by compound of D block element of the periodic table. These defects are classified as metal excess defects, which can further divided into two parts due to anionic vacancy and due to cationic vacancy. So let's start with metal excess defect due to anionic vacancy. When a compound having excess metal ion, if an anion is absent from the lattice site, there it creates a voids while in there occupied by an electron. This type of defect is shown by alkali metal halides like sodium chloride, potassium chloride, and lithium chloride. When alkali metal halides are heated in an atmosphere of vapor of the alkali metal, anion vacancy are created. This anion is then diffused to the surface of the crystal and combined with newly generated metal cation. The electron is lost by the metal atom is then diffuse the crystal and occupy the anionic vacancy sites and form F center inside the crystal. These F center gives a different colors like NaCl gives yellow color, KCl gives violet color and HCl gives pink color. Now, metal excess defect due to presence of interstitial cation. Here, when an excess positive ion is located in the interstitial site, this type of defect is shown by zinc oxide. Here, when zinc oxide is heated, it loses oxygen reversibly. The excess zinc 2 positive ions are occupied in the interstitial site for maintaining neutrality. Electrons are enclosed in the neighboring interstitial site. On heating, zinc oxide turns yellow color by losing electrons and oxygen. Now move on the next defect, which is metal deficiency defect. In this defect, some cation are missing from the lattice side, and for maintaining its electrical neutrality, another remaining cation increase their valency. For example, iron oxide, which is found with a composition of iron 0.95 oxygen, it maintain actually range from iron 0.93 oxygen to iron 0.96 oxygen. In the crystal of iron oxide, some iron 2 positive cation are missing, and the loss of positive charge is made up by presence of required number of Fe3 positive ions. Now move on the last defect, which is impurity defect. We can see here in the molten state, sodium chloride contain a small amount of strontium chloride in the form of impurity in the crystal. Due to the presence of SrCl2, some sites of sodium positive ion is occupied by strontium 2 positive ion. For maintaining the neutrality of the crystal, one Sr2 positive replaces two ions of sodium, and remaining one site of sodium will be vacant. So it is all about defects in solid. Thank you.